This is the problem statement where we had two CSV files. One is the course data and the second is the job data, and we had to create a system, a recommendation system, where for each of the job or for 4 or 5 job descriptions we needed to kind of select or provide or recommend 3-4 best courses that could be suited for that particular job description. So one of the caveat here is that there is no linking between job description and courses. There is no training data that as such that is provided. So we have taken this as an unsupervised machine learning problem that needs to be executed on top of Hadoop clusters. So this is the architecture that was kind of followed. So we had imported the CSV file from the local drive into the SDFS system. We had used the SDFS system here, which in turn stores the data as a CSV file within it. And then we had used Spark on top of it, which utilizes MapReduce at the backend. This we had used to kind of do machine learning on top of it to both train and test the data set. So we had used k-means on the course data to identify about 20 clusters, and each of these clusters were given a prediction cluster number, and that we had used further for testing for the testing purposes. For the testing purpose, what we are trying to do is that we are trying to classify the job data within these 20 clusters that were created on top of the course data. And as an addition add-on, we have also used optimization of the course recommendation, where the course rating was utilized to provide the best course that was available. So a short note on the systems that we have used. So we have used Hadoop, the SDFS here, we have used SDFS 3.2.1. So this is the bin directory that is there. This is the sbin directory that is there. And we have also installed Spark on the Windows system. This is the bin directory that is there. This is again the sbin directory that is there. We have already installed the Python as well in it. So now we will be starting the Hadoop. Open the command in admin mode. So we have the command in admin mode. Now we will navigate to the particular directory where the Hadoop is installed, and we will be using this particular command, start dfs command, to start the data node and the name node. Now as you can see, this has started. Now let's start the yarn and the resource managers. So let's open this. We will have to use start yarn.command. As you can see, they too have started. Now to check whether everything is online and everything is fine, let's just do a JPS command. As you can see, the resource manager, name node, JPS, node manager, everything is active right now. So now let's start Spark. So in order to start Spark, we would first need to do open the command prompt in Anaconda command prompt, run as administrator. Yes. Now we would need to use this particular command to deploy the Spark. As you can see, Spark has started. Now if we go to this particular page, we can see that the Spark has started. Now let's deploy the worker. For deploying the worker, we need to use this particular command. So we are running this command. Now what is happening is that the workers are being deployed. Now if we go back to that particular page that we were seeing, now if we go back to the same page and we do a refresh, we can see a worker node is associated with the Spark session. Now let's start the Spark shell, and we need to use this particular command. Now this will open up our Jupyter. So now that shell command has opened up a new Jupyter notebook for us. So we'll be using the assignment notebook that I have already prepared here. So here all the basic description, the problem statement, everything is provided. So problem summary is also here. Here what is happening is that we are first of all establishing a Spark session. Now moving on to the ML training and testing part. So this is the part where we are loading all the libraries, both the text processing or natural language processing libraries and the MI libraries. Now we would be loading the data, the job CSV file into the data frame, Spark data frame. This is the output from the Spark data frame. Now we are printing out the schema. Now we are loading that data frame into a pandas data frame. As you can see, we did some EDA processing as well. This is the number of output. These are the cases where there are no entries within the job post. So finally what we did was, after the EDA, output of the EDA was that we only retained what was important, that we thought was important to keep for the next level of ML training. This is the second part that we did. We have loaded course CSV, very similar to what we did for job CSV. We have loaded it into a Spark data frame. Then we converted that into a pandas data frame, and we did some EDA on top of it. We also kept some what is important. At the end, what we did was, in order to reconcile both the data frames, we kept both in the course and in the jobs. Similarly, course title is important. We try to do some feature engineering using the course certificate type and adding that into the course title, but we did not find it very useful, so we dropped it at the end. But we did attempt to do some feature engineering here as well. This is that part. So the course ID was important, so it was unique, so we kept it as course ID. This is the output. This is the EDA, basic EDA that we did. This is the value count for the course title. Now we are going to print out the course schema and the course output. So this is the course output, this is the job output. You can see the job data frame output. As you can see, both of them have 4 columns. This is done so that both of them can match with each other during training and also testing. So this is where we are kind of removing all the stop words and all the noise. This will help us in fine-tuning our model by only keeping the token words. So as you can see below, these are the token words that are formed for each of the titles. This is for course title we are talking about right now. Now so the central idea of machine learning here is that we are doing the k-means, and then on the basis of k-means on the course data, we are creating a different cluster. This is where we are doing that training data. These are the different predictions that we got on the course data, and these are the counts. This is the result. Now we will be doing the test data on the job. Here we will be using k-means clusters that we have created as a classification tool here. So we took 5 job samples. As you can see, jobs.samples 5 samples we have taken here. Then we are doing some bit of a processing so that this is in line with the course data frame. This is because the training is done on course data frame, so the testing should also be similar to something resembling the course data frame. So we changed the job post into title. That is where the course title is also there. So we brought everything in sync, and then now this is the output, as you can see here. Then as you can see, we had done a a transform test, and we did the prediction. This is the kind of the output that we are getting. So these are the different selected job posts. Now this is the one below is the predicted output. This is the result output was basically that training data, and the above one is the testing data. As you can see, both of them have prediction columns in common. So here we have prediction number. These are the different prediction cluster, and it is common with this prediction as well. These are the different prediction clusters, like 4 is there, 1 is there, 17 is there. These are the different outputs. We have brought it into pandas for better processing. So now what we will be trying to do is that we are going to use the cluster number that we have predicted from the job and use that to get data from the course matching to that particular cluster number, and then use the course rating as a parameter to kind of shuffle it to kind of prioritize the important ones at the top. So this is an example of that particular case. So as you can see, Citizen Guides National Assembly has 3 different course recommendation. One of them is infectious disease modeling, and the other one is ABC of child. Now another example, these are different examples. As you can see, different clusters are there that are created. This is for predicted cluster 1. So we have different recommendations. Job position 1, 2, 3, 4, 5. There are 5 positions. Now let's go back to the top and do a live testing where we will be reselecting the 5 sample set, and then we will be moving forward. So for that we will need to run all the cells from below here, from below this cell. So now while this is being executed, as you can see from the star, let's go back to the Spark website and see the execution. So as you can see, that application is currently running and 3 cores are being used. Now as you can see, the execution is now complete. Now let's look at the different jobs that were selected and what was it predicted. As you can see, these are the different job postings. So for example, Gritty, this has a prediction number 15. So courses related to 15 was selected here. Now this is for 16. This is for monthly membership. Excel was recommended as a course. Here it is this career center, this unraveling cycling city, this one is selected. So as you can see, the model is working, everything is working fine. Please refer to the Word document for documentation and the Jupyter note for coding notes. Thank you.